Okay, so this time I have a problem of calculating the floor of this summation of 1 over square root of 1 plus square root of 3 plus 1 over square root of 2 plus square root of 4 plus up to 1 over square root of 2017 plus square root of 2019. And well, to solve this problem, you might want to try to solve this by yourself first before seeing the solution. Now, if I start to explain the solution, I will start by this number right here. For example, the floor of this number, decimal number, it is easy that it is just 1178, but this is based on the fact that this number is bigger than or equal to 1178 and less than 1179. So it is bounded by two consecutive integers, and we take the lower bound, and that is the floor of the number. So based on these facts, we now found a strategy to find the floor of the summation. That is, I will let a equal to this. I will let the summation to be a, and now if I can find the bound, that is two consecutive integers n plus 1, such that a is between those two numbers, then we can conclude that the floor of a is equal to n. So we must find the two consecutive integers that bounds a. So how can we do that? We can do that by, first I will simplify the a to make it easy. Start from the first term, multiplying the conjugates, I get this, and this is exactly this, square root of 3 minus square root of 1 over 2. And then for the second term also in a similar way, because we have the denominator, the square roots has difference of 2. Again, we have this, square root of 4 minus square root of 2 over 2. And we can continue this up to the 2017 term. We get this simplified form, that is square root of 2019 minus square root of 2017 over 2. Now we see plus minus pattern here, plus minus and then plus minus again, and so on. And maybe we can get a telescoping pattern here. So this is the new form of a based on our findings, and so on. We get a pattern of plus minus, and up to square root of 2019 minus 2017, square root of 2017. And now we see here that square root of 3 here is cancelled by another minus square root of 3 over there, and they become 0. And then square root of 4 also will be cancelled by minus square root of 4 somewhere over here, so it will be cancelled. And then also the square root of 1 minus square root of 1 minus square root of 2 are okay, and then square root of 5 also will be cancelled here by minus square root of 5 somewhere over here. So minus square root of 1 and minus square root of 2 are not cancelled by anything, and this is also not cancelled because there is no minus square root of 2018. And then again, this number here will be cancelled with plus square root of 2016, and also this minus square root of 2017 will also be cancelled, and 2019 will be saved. And so we get all cancelled here, and we get only they are equal to half times square root of 2019 plus square root of 2018 minus square root of 1 minus square root of 2. So we have a is equal to this number, and let's try to find an upper bound. Let's make it as close as possible. We start from 2025, the square root of 2025, and then minus square root of 1 minus square root of 1 over 2. That is close enough, and this will be equal to this minus 1. And the square root of 2025 is exactly 45, and we have 44 here. Maybe this could be the n plus 1. To check that, we must check whether a, so we get that this is the upper bound, and now let us check whether a is bigger than or equal to 43. So if we can prove this, then we are done. The answer will be 43. Now let us check this. So we start here again. Start from here. Then it is bigger than or equal to, very close here. 20. Both are square root of 2018, like that, over 2. That is easy to check. Very easy. It is just square root of 2018. Square root of 2018, and then for the other one, minus square root of 1 minus square root of 2 over 2, we have here bigger than or equal to minus square root of 2 minus square root of 2 over 2. So we have only minus square root of 2. So we get another simple form here. That is, we know that a is clearly bigger than this. Now, is this bigger than or equal to 43? We want to show that. We want to find out whether this is true. So we can just square the numbers. We square the numbers and then we compare which one is bigger. So we compare 2020 minus 2 times square root of 4036 and with the number 1849. So the difference between 2020 and 1849 is 171. So now we must compare this 171 with minus 2 times square root of 4036. So now we compare. We want to show that we must check whether this is less than or equal to 171. So again, we use square numbers. We will square both sides. We will square the numbers on both sides and we compare them. This 171 squared is, and we just expand. This is just 100 plus 71 squared. This is 10,000 and then plus 14,200 and then plus 71 squared. This doesn't matter, but I know that this is bigger than 20,000. We don't need the exact value. You will see why, because this number, if it's squared, it is just 4 times 4036. Now this won't reach to 20,000, so it must be less than 20,000. So it is less than 171 squared. So we found that the inequality is true here, and this also means that if this is true, this also means that the above is true, that square root of 2018 minus square root of 2 is bigger than or equal to 43. And so we also found that a is bigger than or equal to 43. So we found the lower bound and we found the two consecutive integers that bound the number a. So the answer, well, we know that a is bigger than or equal to 43 and less than 44. So the answer to this problem is, since we know this is true, then the 4 of A should be 43. So this problem has the answer 43.